Hello and welcome everyone to the Carbon Negative Understanding Net Zero in Challenging Times. This is one of the many MNIS insights online, so warm welcome. Today you'll be having three presentations, one from myself, one from Dr. Winifred Germana of the Scottish Institute for Remanufacturing, and one from Andreas Remier, all relevant to net zero and sustainable practices. Just a bit of housekeeping. This webinar is being recorded and will be made available on our YouTube channel. So if you'd like to revisit, we welcome this. Your microphones and webcams will be turned off during the session to avoid any background noise. And you can type any questions throughout the session via the chat tool. If you have a question, please mark it as Q. If you have a comment, please mark it as C, and we'll review them at the end of the presentations. Time will be allocated at the end for speakers to answer any questions you might have, but we'll also provide contact details so you can reach out at the end. Using the hashtag MNIS Insights for any questions on Twitter. Please take some time to complete our survey because we do value your feedback and understanding if this has been of use. So what is the National Manufacturing Institute Scotland? So this is a group of industry-led manufacturing research and development facilities where research, industry and public sector work together to transform skills, productivity and innovation to attract investment and make Scotland a global leader in advanced manufacturing. Quite topical, especially around net zero. We will seek to increase productivity by reducing barriers of innovation, stimulate investment and increase manufacturing competitiveness across Scotland, try to be a catalyst for job creation and strengthen supply chain links or reshore supply chain, and inspire and attract talent and equipment current and future workforces with the skills they and the businesses need, particularly for a sustainable future. Work with manufacturing businesses of all companies and sizes and different sectors, and even working with the overseas challenges to bring opportunities to Scotland's shores for Scotland's supply chain to take advantage. MNIS is part of one of the Scotland team, operated by the University of Strathclyde and supported by the following partners. MNIS is made up of specialist technology centres, no surprise to you, such as the Advanced Women Research Centre and the Lightweight Manufacturing Centre, as you may well know, are already well established and in operation. We are not awaiting for the Manufacturing Skills Academy or Digital Factory or Collaboration Hub to physically open. Work has already begun and open for business, so we welcome any engagement to these programs. So in summary, the new MNIS building has been approved, and although not open, work has definitely begun and support is available to you to take advantage of today. So this particular webinar is based around the net carbon zero and also the challenges or opportunities it's presenting for the future of Scotland's supply chain. So what does this mean? Well, there's four key aspects that you're probably well aware of. Carbon sources will be measured and monitored in the future. A focus to eliminate sources of emissions where possible will be pushed. Where not possible, there will be a focus on reducing emissions before offset activities are accepted and more focus on sustainable practices. Focus on improved levels of verification, ensuring compliance with net zero carbon goal will be future goals and future programme aspects. Just to make you aware, the High Value Manufacturing Catapult have actually established a circular economy working group. I'm one of the technical leads, and as part of our initial activity, our first action was to establish a roadmap around the circular economy, identifying key challenges and areas of opportunity for the UK manufacturing, and importantly for the high value manufacturing sectors, including net carbon zero. 13 sectors were reviewed, gap analysis was undertaken, and an understanding of the technology needs were also reviewed. And what we were able to identify was some common cross-cutting sector themes that will be topics of future insight events. Some information is retained in the following presentation, however, we're not presenting all of the findings for each sector. It's fair to say that progress towards a circular economy is critical for meeting net zero carbon. We view these going hand in hand. New principles in design and production of sustainable feedstock, materials and products, combined with an emphasis on supporting the development of sustainable energy orientated solutions, is key to achieve this. It's also worth mentioning that the UK is responsible for around 30% of the greenhouse gas emissions. It also is driven largely due to downstream consumption emissions via the products it manufactures across the global supply chain. So this presents a big opportunity if the UK supply chain can embrace a circular economy, offering up environmentally sustainable services to offset the carbon footprint and also to recover value and utility of the existing value stream or feedstock in service today. It is fair to say that previous industrial revolutions by nature have placed huge burden on the environmental focuses on mass production, cost down, and fast lead times to market. Poor developing nations still struggle to grasp the benefits of a more sustainable or circular economy approach. And huge burdens are placed on the Earth life cycle and sustainability of consumption of the materials and energy requirements. Industry 4.0 must be different as well in order to deliver this sustainable practice and sustainable ecosystem. Many business leaders will be challenged. Companies may not have the right culture, skills, and thinking in place to address this and harness the opportunities. However, the world's biggest challenges are the world's biggest opportunities. This convergence is ripe for new, innovative entrepreneurs, and there is a need to ensure that the right provisions of collaborative research and development programs are in place and strategically targeted to help innovative firms to address the right challenges around the sustainability and net zero challenge. It's also identified that there is a great opportunity in the convergence of two powerful forces. It's viewed that the digitalization of value streams, of waste streams and material flow will be key to unlocking a sustainable future and to unlock the value proposition in circular economy. It's also recognised that there will be a change in practice within organisations. A good one is Kodak was originally a chemicals business. However, in reality, their new business helps people to capture and share memories at this time. And the same could be said for companies entering into the circular economy and net zero supply chain. It could mean a change in their business models or an understanding of how they can provide value add and value propositions to this sustainable future. This, however, it's fair to say that current practices based on the linear economy is no longer sustainable, and this will challenge the way in which designers, engineers and leaders are needed to focus on their skills development, methods and tools of design. It's understood that 80% of the environmental and social impacts, including the greenhouse gas emissions, could be designed out at design stage. However, this is only part of the solution. It only addresses the future products. It doesn't, however, address the challenge that we have at the moment of residual carbon and current assets that we have in service and could pull value on and could develop supply chains or value propositions across the Scottish supply chain. So part of our focus within NMIS and within the High Value Manufacturing Catapult will be to identify and work with supply chain to identify those opportunities in utilising secondary material requirements, looking to recover materials, looking to reprocess materials in a sustainable means, achieving lower carbon emissions, achieving better carbon capture within the assets that are already in circulation, to understand how technologies can enable recertification, recovery and redeployment of materials, and how this will in turn impact the value stream and the life cycle of products. In the top right is a good diagram of our approach in terms of the material value over a circular product life cycle, where we're looking to not only work with products following their deployment into their environment, but also the recovery, so it doesn't need to go back to a smelting stage, but can be recovered at an earlier stage, so that retained carbon footprint within that asset, within that component, can be offset for its next life cycle, whether it be in its original sector, environment or deployment, or an additional one for the future. It's worthwhile saying as well that the Internet of Industrial Things will be a key enabler to track the record of the asset, of the material, to understand its value, to understand its carbon footprint, and to potentially understand where it could be redeployed and how we can create value in our supply chain to repurpose, redeploy, and resell. A good example of this is within the renewable energy industry, where we see opportunities for repowering wind turbines, recovery of decommissioned wind turbines, reservicing of the key components that have long lead times, and redeployment within the value stream that hold a higher value to the supply chain than originally the value of it being sold as virgin material or virgin feedstock. An additional area where we are focused on and trying to help educate the supply chain is around through life engineering and digitalization, offering the opportunity to condition monitor asset, but also understand how new suppliers, SMEs, can actually feed into this. Because you don't necessarily need to be remanufacturing products. You can actually be offering the services in terms of recertification, validation, traceability, or track record of that asset to understand how to repurpose, how to redeploy, and to address some of the barriers that are presented in the sustainable future circular economy frameworks and achieving the net carbon zero ambition and goals outlined. So hopefully in the next two presentations, what we'll do is we'll present to you some of the lessons learned from the Scottish Institute for Remanufacturing and some of the great work that they're doing, but also some of the work that's been undertaken within the MNIS team for some of the exciting new test beds that we're creating to help industry adopt the practices, develop the required skills, but also understand what the new potential value propositions can be within this net carbon zero supply chain or value stream. Winnie, over to yourself. Hi, Winnie, you're on mute. Can you?
I'm just trying to share. Yes. Oh dear, where's my? Okay, right. Good morning, everyone. I'm Winifred Ijima. I'm the Technical Director for the Scottish Institute for Remanufacturing. We are a Pan-Scotland Expertise Centre established to spearhead the secularisation of the Scottish economy using remanufacturing. We have two key aims. The first one is to increase the number of remanufacturing operations in Scotland, and secondly, to increase the capacity and innovation of existing remanufacturing operations working in Scotland. We're achieving those aims using four key methods. Oh God, it's not moving.
Winnie, maybe if you do kind of update now and hit present mode.
Yeah, okay. Could you move the first one? You've missed one out.
Yeah,
okay.
We're not controlling. Yeah.
Okay. And these four methods are, firstly, we raise awareness of remanufacturing and its benefits. We transfer knowledge around the remanufacturing industry to spread best practice. And we build networks for remanufacturers to increase the strength of the voice of that industry. Lastly, is that we fund industry-driven projects, provided that they meet two criteria. The first one is that they must show measurable benefits for the company in the terms of increased performance in economic or environmental aspects. And the second one is that there are collaborations between industry and academia so that we can bring together the wealth of knowledge and expertise in those two sectors for the benefit of the remanufacturing industry. And as you can see from the bottom of this slide, as of the end of last year, 2019, we'd already given out more than £800,000 to industry to enhance operational performance.
Sorry to interrupt, Winnie, are you able to put these slides on full screen view? So that presenter view? That would be fantastic.
It is on full screen, yeah?
We can see them, but if you just
there we are. Okay.
So sorry, Winnie, we can see your notes, so we need that screen.
Okay, remanufacturing is a different way of making products that enables us to produce high value products, but at significantly reduced production costs and energy savings. We're talking about producing the same quality of products as conventional manufacturing, but at up to 80% cost savings and up to 80% energy savings. This then enables producers to hugely reduce the selling price of their products so that we, the consumers, can obtain high quality products at vastly reduced prices. And the reason that we're focusing on remanufacturing is that government the world over, UK, Scotland, China, Japan, and China, even the US, have identified in their reports that remanufacturing is critical to industrial sustainability. For example, by the year 2030, remanufacturing will be responsible for £511 billion in trade, creating 580,000 jobs while saving 450 million tons of CO2. Added to that, remanufacturing is also an enabler for lucrative emerging global opportunities, such as the circular economy and low carbon manufacturing. However, the practice is hindered by some major issues, such as lack of appropriate models and technologies, and poor social attitudes and awareness. We identified that increasing the extent of remanufacturing provides opportunities throughout the whole economic chain, from design through to manufacture, through the supply chain, and back through the resupply chain. Even people not involved in remanufacturing can get involved by, for example, developing service models or tools, techniques, and concepts to enable us to design products that can be remanufactured. And this is highly important because the key issue for remanufacturing at the moment is that there are a whole array of products that cannot be remanufactured at all simply because of their design and manufacturing methods. We found that the remanufacturing industry was hugely diverse, a whole array of different products being remanufactured, and the high growth sectors were automotive, aerospace, ICT, and energy. But there were also some sectors which are just coming to the fore and that will be important in the future, such as medical equipment remanufacturing. We found there was a huge different array of confusing terminology used to describe remanufacturing, and some of these were quite inaccurate. In the UK, for example, if I go to the aerospace industry, they don't talk about remanufacturing, they talk about repair and overhaul. If I step across the road and I go to the marine industry, they talk about re-engineering. If I step out the country and I go to Japan, they use terminology such as inverse engineering. And this makes it extremely difficult to size the remanufacturing industry and even to develop tools and techniques that it needs to be optimized. In terms of how business is conducted, we found that typically trade is business to business. There weren't that much business to consumer in the remanufacturing arena. We found that remanufacturers want technological expertise, but what they require most was the softer technologies, such as business models, more than the hard engineering ones like implementation of robotics. We also found that compared to conventional manufacturing, remanufacturing was very low technology level. Having identified the huge amount of opportunity available via remanufacturing, we then looked at the capacity for Scotland to access this huge industry, this immense opportunity. And what we found was Scotland does have the characteristics to get the lion's share of this. In Scotland, we have the right mix of skills, industry, and a ready workforce. For example, the key expertise we need for remanufacturing is engineering. And Scotland, particularly the west coast of Scotland, is awash with this because of its shipbuilding past. In Scotland, we have another advantage, the good transportation network round the country and getting into the country as well. There isn't any area of Scotland that cannot be accessed by one means or another. But in addition to the ease of air, road, and rail access, we also have sea because we're an island. And the simple fact is that the bulk of these equipment that are now remanufactured are big, chunky bits of kit, and they move by sea, and we have the ports to accommodate them. However, we found that there were weaknesses in the current system that prevents us getting access to this huge opportunity. We found very few examples of legislation and incentives that would support remanufacturing. We found that although Scotland had abundant expertise to get on board and exploit and optimize our chances with these opportunities in remanufacturing, the expertise was dispersed and therefore is currently not being marshaled effectively. And lastly, we found that to engage, industry needs new products, services, innovative business models, but they lack the wherewithal from the point of view of capital and expertise to develop the necessary technologies that they need to access remanufacturing. And the reason for this is that remanufacturing is highly complex, much more so than conventional manufacture. For example, to operate remanufacture effectively, we need a whole range of different disciplines and different sectors coming together and working well together. And currently, these sectors, some of them don't even communicate, never mind work together. So, having identified the huge opportunities, Scotland's strengths and weaknesses on getting on board and grabbing its fair share of this, we then try to find out what needs to be done to break this gridlock. And we found it cannot be done without government intervention. There's a need for government intervention to address the technical and non-technical hindrances preventing Scotland from getting on board these huge opportunities. For example, a key technical hindrance is the lack of available, appropriately trained personnel and certified training programs for the industry. Within the whole of the UK, within Scotland, within the whole of the UK, there is not a single national recognized or certified training scheme for remanufacturers. Remanufacturing itself doesn't appear anywhere in the national curriculum, apart from the classes that are taught at Strathclyde University. We need support from government to develop these essential courses to provide a pool of relevant skilled labor to man the remanufacturing industry. There was also a need to establish mechanisms to facilitate the complex collaborations required to engage with remanufacturing effectively. And here, I'm talking about centers of expertise, a focal point to bring together these disparate groups and disciplines and to facilitate their working together and working well together. And here, Scotland has made a start and deserves praise for that, because it has established at least the Scottish Institute for Remanufacturing. However, more needs to be done. There is a need for support from industry to tackle the non-technical hindrances. And here we're talking about things like pro-remanufacture policies, such as tax breaks, in recognition of the goodness of the industry for the country in addressing the adverse impact of production on the environment, in addressing social exclusion by making available high quality products at highly reduced prices so that low-income families can buy them, in creating employment across the board, in helping us reshore our raw material, taking into account the expected disruption in raw material in the future because of their shortage and because of political issues around the globe. We also need legislation to support uniformity of standards in the remanufactured sector in order to raise customer confidence, because a huge hindrance is that customers are hesitant to purchase remanufactured products because they're unsure of the quality that they will receive if they purchase remanufactured products. We need legislation that can enable us to define and differentiate remanufacturing from lesser forms of reuse, such as repair, reconditioning, etc. Last but not least, we need governments to lead by example. It's not nearly enough to write reports, fancy reports, saying how critical remanufacture is, how wonderful it is. We need government to use remanufactured products to show their endorsement. How about when we refurbish government buildings, we use remanufactured equipment, remanufactured office equipment? This is an example from across the pond. In 2015, President Obama signed the Remanufactured Bill, which mandates the head of federal agencies to use remanufactured parts when maintaining the federal fleet. Not only did this reduce hugely the expense of maintaining the federal fleet, but it was also a clear show of endorsement of remanufacturing, not just remanufacturing industry, but of the quality of remanufactured products. Today, 5 years from then, if you go to the US, people don't hesitate twice, not even once, to purchase remanufactured parts because their government has endorsed it and their government uses remanufactured products. So we need something like that to happen here. So the Scottish Institute for Remanufacturing, we are a Pan-Scotland Expertise Centre, and we were established to spearhead the secularisation of the Scottish economy using remanufacturing. Our key remits were to, firstly, to increase the number of remanufacturing operations within Scotland, and also to increase the capacity and innovation of existing remanufacturers, thereby increasing their productivity and their competitiveness. We build networks for remanufacturers, and also we transfer enabling technology and knowledge around the remanufacturing sector in order to enhance best practice and spread enhanced best practice. We develop toolkits to assist industry. For example, we have the Remanufacture Competency Checklist, which enables companies to assess for themselves their capability to remanufacture, and if they so wish, to come to us to work with them to develop an action plan that will enable them to successfully integrate remanufacturing into their business. We also have a Design for Remanufacture toolkit, which gives people an idea of what's involved in designing products that can be remanufactured. We run workshops aimed at enabling people to be able to properly differentiate remanufacturing from alternative forms of reuse, such as repair, reconditioning, and repurpose and recycling. And also gives people a tester of designing remanufacturable products. I'd like to thank you all for taking the time to listen to our presentation today. Please contact us if you want to learn more about what we do in the Scottish Institute for Remanufacturing. I'd also like to remind you that our October series of seminars begins in a few weeks' time. If you're interested in learning more about remanufacturing, we have an Introduction to Remanufacture webinar on the 5th of October. So thanks a lot for your time today, and have a good day, and we hope to see you soon.
Thank you very much, Winnie. That was a very good presentation. And I'm also aware that SIR's just recently launched their website, so it's definitely worth a view for participants to go in there and see some of the new aspects to SIR as well. So Andreas, it's time for your presentation.
Yes.
Are you to share?
Yes, I will. So I hope you guys can see the screen.
So just a reminder to parties, if you could please, while Andreas sorts out the screens, if you could please post any questions that you have in the Q&A or any comments you'd like to raise based on the information you've heard on this webinar, and we'll come to those following Andreas's presentation. Over to you, Andreas.
Can you see the screen?
We can, yes, loud and clear.
Perfect. So yeah, thank you very much, Winnie and Paul, for your presentation. I'm Dr. Andreas Reimer, and I'm part of the AFRC NMIS team, and I'm leading the ReMake testbed. So today I'm talking a little bit more on the practical side of the remanufacturing. So the AFRC NMIS established the remanufacturing team actually around 2016, where we looked at fairly basics in remanufacturing. And since then, actually, the theme and testbed now has grown every year in terms of numbers and sizes of the projects. And now it's a very key point of the strategic and themes and testbeds in NMIS. And currently we're looking into developing, obviously, further capabilities in ReMake, especially we're looking in using additive manufacturing to reduce carbon emission in components. I will talk about this one in a bit more detail in the coming slides. We're also investigating in cleaning, in automation, digitalization for remake and machining, as well as standards and guidelines, as Winnie mentioned in her presentation before. So it's a very key point in remanufacturing to gain trust in this technology. So also needs to be said, so remake and or remanufacturing can be used across many sectors. So it's not only we establish maybe something for an aerospace sector, it doesn't mean it can be maybe applied, for example, in oil and gas. So there's always a crossover, and which we want to obviously utilize to reduce carbon emission, lead times, and so on. So as I said before, we're looking into novel ways for using additive manufacturing and in remanufacturing. So using additive in remanufacturing really enables us new possibilities in terms of repair and remanufacture, because some components were not able or not possible to remanufacture before, which are now there using AM. And also we can maybe change materials and so on, so which will enhance actually the life of the components, which you will see in a minute. Furthermore, often used technologies are, for example, DED, and specifically wire arc additive manufacturing, laser metal deposition, powder. Those are two technologies which we have already established in the AFRC NMIS, as you can see here on the right-hand side. Powder bed fusion can also be used for remanufacturing. Cold spray is often used, binder jetting, and even material extrusion like the FDM. So, as you may be aware, so additive manufacturing is not always the most precise technology. So we always need some kind of pre and post processing, especially machining, and to bring the component basically back to size. So the machines have a very high precision, which allows us to really get back to the original dimension required for the component which has been remanufactured. We also use additional software to increase the accuracy, to really make sure the parts are less deflected and actually are in the required geometrical tolerances. We also use, we also have equipment where we use CMM to make sure that the part is really accurate. But one challenge is obviously to really get the heat treatment right, because the components maybe need to be post-heat treated again. So this obviously gives us some challenges, but also some opportunities obviously in the future to look forward. So I would like to talk about basically two projects on remanufacturing. We have two, which is one is the die remanufacturing. So we have one is the where dies have been remanufactured and using LMD. So those forging dies obviously have to withstand very high pressures during the forming process, forging process. It's about 1,000 ton press and temperatures up to 1,250 degrees. So it's a very harsh condition. And also I will talk about an oil and gas component which has been manufactured, which can be also remanufactured. So those kind of crossover components also have to withstand very harsh condition in terms of corrosion, as well as high pressures inside and outside of the pipe. So that the first project is called DigiTool. So DigiTool is an Innovate UK project, and the basically it forged two buckets, bucket tees, sorry, for Caterpillar. And so, as I said, so we have there very high shock loads, high pressures, thermal loads, and those guys, as you can see in the top picture, they got a very high wear rates. So, and which leads to inaccuracy of those kind of bucketies, which didn't allow them to manufacture them further. So they had to throw them afterwards. So the project itself is basically looking into establishing a hybrid manufacturing process to remanufacture those dies. And so the dies were optically measured, so it was then cloud processed, so then adaptive cam cycle and C programming was established. Then we machined down the worn area to known size, filled it up with LMD powder. So, and then did another finishing machining on it and did a snooze blending. And obviously, in the end, we did a final scan to really see if the component has the required standard. So here you would see a little bit of a demonstration of it. So here, so the first picture is as it is original, then after it was worn. So you can see here some markings of the worn areas, was then deposited. As you can also see in the picture, in the video. And then in the end, it was machined down to size. So the original life was about 1,300 parts. After this, the company scrapped it. So it's a fairly big part, which is made from H13, which is a tool steel. And so using the remanufacturing, so it was then remanufactured using Sterite 21. It's a hard-facing alloy, and it allowed the part, again, 1,400 components to manufacture. So we extended, not only doubled the die life, but we even extended it by 108%. So the total amount we got actually out in the end is 2,700 parts instead of 1,300. So the second project was a joint industry project with DNVGL. So we developed actually a guideline for oil and gas applications. So it's not a remanufactured component as such, but it can be used to remanufacture components. That's why I'm presenting this one here. So it was a generic crossover demonstrator where those kind of components usually have to withstand very high pressures and corrosive environments. So we warmed the entire crossover using Inconel 718, so which allows us actually to have very high deposition rates, so the component can be manufactured very high and very quick. And the material consumption obviously is much less than if you would machine it from the full. So even using just the additive on this one will already reduce the carbon emission significantly. So we carried this project out with some our partners, Valorec, which is a very big OEM for oil and gas, and they carried out a burst test, and it was able to withstand internal pressures up to 15,000 psi, and and compression loads up to 1,800 kilonewton. So at an elevated temperature of 130 degrees. So which is a lot of pressure. So, and the pressure limit, so they then said, because it wasn't breaking at 15,000 psi, so they brought it even higher, up to 30,000 psi, where it started to slowly crack. So it is way above the required limit of the pressures. So what we can actually learn from today is basically we can use for visualizing and prolong components life cycle. It will definitely reduce the carbon emission, and we also are able to use to reduce lead times and warehouse, which all contributes to the CO2 emissions. And so we just need to further develop a broader acceptance, as Paul and Winnie already mentioned in their presentation before. And yeah, so it also can obviously withstand very extreme conditions. That's me. Okay, Q&A. Thank you very much.
Thank you, Andreas. Thank you very much.
You're very quiet, Paul.
Sorry, that's because my speaker was on my head. My apologies. So thank you very much, Andreas. Very informative. So what we're now doing is we're moving to the Q&A segment of this program. What we ask is parties please raise any comments or any questions in either the chat or the Q&A box, and we'll address them. I see two already. There's one comment that I'll invite the panel to comment on after. So there is thinking that focus of government support should be along the lines of carbon tax and regulation of waste and waste streams. It is then for society, academia, industry and engineering, environmental, professional institutions to work out whether and how to create markets. I would be concerned if time, effort is expended trying to persuade government to establish training systems, national accreditations, and so on. So Winnie, do you want to take that one first? I'll give you first.
Yeah, I think it is true that we need things like the government to sort of either penalize people for the amount of carbon or reward the remanufacture industry for their sort of lowering of the amount of carbon generated. But we do need training schemes, because at the moment we have an industry which can help us, and they don't have the pool of skilled labor. When a remanufacturer wants to employ more people, they don't go to the job market or anywhere else. They just bring in anybody, and that new trainee learns by watching another person. Which means that training is inefficient, because depending on the sort of on the relationship between the new recruit and the more experienced person, training might not be effective. Also, because the person training never went through a formal training scheme themselves, the expertise that they are passing on is not really the best. We do need a training scheme for remanufacturers to provide a ready pool of trained workforce for the industry.
Thank you, Winnie. Andreas, any additional comments?
No, so I agree with Winnie. Obviously, we need specialized people for manufacturing, and that's basically where, especially the NMIS is looking into. So how we can actually train people to get this specific skill set. So the good thing is, obviously, a lot of the knowledge is already transferable. So, so we need additional skills. Yeah.
Yeah. So it's really a two-pronged approach we're talking about. We need training, but we also need legislation. It cannot be either or.
Yeah. I think it's also fair to say that we're aware that right now government are trying to work out what the breakdown is of the actual carbon footprint of our manufacturing industry, but the risks associated to the level of import that we actually have, as kind of demonstrated in one of the schematics I threw up. And I think also, if we do not start in the UK or Scotland to address this, we are aware that other centres and other regions are already making headway in sustainable practices in high value industries. And when it comes to operators and OEMs issuing contracts, invitations to tender, and you're asked about track record, again, it might be a case as identified when the renewable wind industry was established, that we were second to the post, and that cost the UK supply chain quite significantly in trying to create local content and local content in terms of manufacturing the high value products that we're only now recovering. So I'll move on to a question that was raised. And the question is, how does Scotland compare globally in remanufacture space? Where does our comparative advantage lie? If you could make one recommendation or change to spur remanufacturing innovation in Scotland, what would it be? So I guess we can address that in three parts. And Winnie, being the director of SIR, I think that's probably a good place to start, and then Andreas, yourself. So the first part is, how does Scotland compare globally in remanufacture space?
Okay, well, actually, it's unfortunate that actually we only had a very limited amount of time for this presentation, because that was on the slides that I took out. The simple fact is Scotland was doing quite well. Around about 5 years ago, we were meant to be the leading nation. But what happened was we established a center of the Remanufacture Institute. Then Germany came on a few months later and established one. And then we've had the Basque Country, who then established something similar. So the worry is that what happens is like normal British thing. We have a good idea, then we sit on it, and somebody comes out and jumps on it. Another thing we should be aware of is that China has, since the year 2000, been having remanufacture on its 4-year plan every single year. It's also got one for the circular economy. And according to the Chinese government, remanufacture is their plan for how do they put it again? Is their plan for industrial sustainability and also for overtaking the West in production. So they're looking at it as not just a case of we're going to need this to save our country, is we're going to use it for leapfrog effect as well. So I think we need to do something. And we find that so in a way, if we don't continue moving, we're going to fall backwards, because other countries want to grab a share of this market, and quite rightly so.
And just for the second part, I suppose, Winnie, where does our competitive advantage lie? And if you could make one recommendation or change to spur remanufacture innovation in Scotland, what would it be?
I would say, to be honest, I would say there's two-pronged approach. We need the policies, but we also need the skilled people. We've got a very, very important industry. There isn't a pool of ready pool of workforce for them. And also, when people think of remanufacture, it's almost as if it's garage compared to conventional manufacture. So we need awareness of remanufacturing, what it is. We've done a lot of work with it in the Remanufacture Institute, but more needs to be done. We actually need government to show by example. You know, we've had governments produce reports saying how important remanufacture is, how good it is, but we don't actually see them using it.
Thank you.
So really, yeah. So it's a complex thing. We can't just pull out one thing out the hat.
Yeah, Andreas.
Yeah, so it was quite a few questions. So I think the strength is definitely in the manufacturing. I think so, because I see it. So we have already in Scotland quite established manufacturing, and also a few companies who are practicing remanufacturing actively. It's almost their major main business, and more companies coming and establishing it as a side business and actually seeing the opportunity and growing it. So that's why I think Scotland definitely has there an opportunity, and that's a strength, but it needs to be from the government. It needs to be pushed further to let it grow. Yeah.
Great. Thank you. I guess from my side, if we were to look at the where does our comparative advantage lie? So touching on what Andrea said, just to draw some attention to certain sectors. So in the UK, especially Scotland, we have a very strong automotive remanufacturing supply chain and a very strong waste remanufacturing supply chain, both for commercial or IT equipment for offices. That's been very well established. They've worked out means in terms of retesting, recertification, redeployment. And where we see an opportunity for growth is in the ambition of the energy transition, where Scotland is the target market for renewable energy. However, we don't have any UK supplies or content, but what we do have is very old infrastructure where there's a huge market opportunity to recover that old infrastructure, remanufacture, repower and redeploy to meet our own requirements and our own ambition for sustainable energy of the future. But also we can look in terms of the logistical infrastructure, such as rail, where we have an aged infrastructure that we could look to deploy more sustainable practices, more through-life engineering services, and more kind of service offerings where the OEMs or the operators, after the initial 5 years of service of the components, and that's excluding aerospace at this time, are seeking alternative value streams and supply chains who could deliver in a leaner time frame and a leaner cost, but also verify the quality and the integrity of work. If we could make one recommendation or change to spur remanufacturing innovation in Scotland, one from government, yes, completely agree that government does need to drive this through incentivization. Secondly, through the academics to create frameworks to help certify and recertify the remanufactured products, and industry to start setting the challenges. You know, we welcome to hear some of the products you would love to see local content be able to manage, to be able to servitize, to be able to remanufacture because of the age of the asset, and then for us to broker those communications with the existing value streams that already reside in the remanufacturing or circular economy marketplace, but could transfer their capabilities, their skills and their practices into new market opportunities, but bridge that line of communication to manage and share that risk within industry. So I see no more questions. I'll just give parties an opportunity to raise any more comments or questions. No, okay. So all that's left is a very big thank you to everyone who's participated in today. Thank you very much to the speakers, very informative and useful presentations provided there. And thank you to the participants. Just a quick reminder, please do provide feedback, please do fill out our surveys, and please do get in touch. We want to hear what your challenges are around the circular economy and the net zero ambition. Thank you.
Thanks very much, Paul. Just to reiterate, thanks very much to everyone for joining us today, and thanks to our presenters. As Paul mentioned, there will be a survey gets issued at the end of the webinar, and we would appreciate it if you could take a few minutes to complete it and return it to us. It does help us shape future webinars. If you want to get in touch with us after the event, you can email us at nmis-inquiries@strath.ac.uk. Thanks very much, and I'll just shortly bring the webinar to a close. Thank you.